All right. So this week, we're going to be doing a lot of work with the graphing calculators. And I need you guys to pay super close attention to what we are doing. Okay? Following along, hitting the buttons with us, and making sure that you are doing what you're supposed to be doing. Once it shuts off, let me know if it shuts off. Okay? Okay, so that's another thing. A lot of you, your batteries will say that they're low. When the batteries get low on these, they're good usually for another month. Okay? They say that they're low super duper early. So once it starts shutting off on you, let me know and I'll grab you another set of batteries. Okay? Alright. So I'm kind of going at this as super important because I look around the room and some of us are already typing stuff in on our buttons, on our calculator and stuff, and playing with our calculator. Here's the deal, guys. If you don't pay attention and know what we are doing, the quiz that we have on this next week is not going to be very fun. Okay? Because during that quiz, I'm not going to help you on which buttons to push and that kind of stuff. Okay? So it's super important that you guys are following along with what buttons we need to push. Okay? Now, what we're going to do right now, you only do at the beginning of each class period. Okay? We're not going to do it every single, you don't have to do it after every problem or anything like that. We just do it when we come into the classroom. So, what you're going to do is you're going to hit second plus sign 7, 1, 2. And it should say round clear. What that does, the Algebra 2 classes use these calculators as well. So what it's doing is it's what they've been doing on their calculator. It's taking it off and getting it ready for what we want to do. Alright? So, right now, it gives us the equation on the top of page 72. It says that if a penny is dropped from the roof of a 400-foot tall building, the height of the penny over time can be represented by the equation negative 16t squared plus 400. What's that h stand for?
Right.
The height. What's that t stand for? Time. Good. All right. So to graph this equation, we're going to go to y equals. Okay, and that t we're going to represent with an x. Okay, so we're going to hit negative, and be careful, you have to use the negative sign that's underneath the 3. Okay, you can't use the minus sign. So we're going negative 16. X is the button that's next to the alpha key, or below mode. It's like x, t, there's a theta on there, something else. Okay, and then squared is underneath the math key. Oh, no, just kidding, it's not. That's not the right one. Oh, yeah. It's one next to your parentheses. Oh, man. I'm just going to have to start over. Negative 16x squared. All right, so does everybody have negative 16x squared? Yes, sir. Huh? Shutting off. Okay, and then plus 400. Okay, I'm going to pause this. All right, so everybody hit graph. Is that the picture that you guys come up with? All right, the hardest part of these problems on your graphing calculator, and most people will tell you this, is figuring out what your window should look like. Okay? Because it's kind of a guess and check type of thing. So these first couple problems, they're going to help us kind of figure out what our window should be to be able to see the whole problem. Okay, but then after that, it's kind of a tough gig. So we're going to hit window, which is next to our y equals. All right. They tell us to change. So what this is telling us is our x. Okay. So our x's, remember, go across, right? So this is telling us that our x's should go from negative 10 to 10. We have a scale of 1. telling us that our x, or our y, is going to start down here at negative 10, and it's going to go up to a positive 10. That's what that's telling us. Okay? Now, it tells us to change our y max value to 400. Why do you suppose we want our y to go up to 400? Well, right now it stops. It was stopped at 10. Because we want to be able to see it, because where was our starting point? It goes up to 400, yeah. So I'm going to hit graph now. And now now it looks like that, right? All right. So then number 3 says, why might it not make sense to show negative x values on this graph? What is x representing? Time. So why shouldn't we do the negative x values? Yeah, because we can't have negative time, right? Okay, so I would write that in number 3. All right, because this is what your grade is going to be on, is could you follow along with this? All right, so it might not make sense to have negative x because time is not going to be negative. All right, so now it's telling us to go back to window, and it says to change the x min, which is where we're at right now, to 0. We don't need those negative x values, right? All right, so now we're going to graph. Does the picture that you have on your calculator match the picture that's on your paper? All right, so they want you to put a B at the top of the building. Where's the top of the building going to be? That highest point. So right here, they want you to put the letter B. So on your paper, you're going to want to put a letter B at that highest point, because that's where the top of my building is. And then they want you to put an X where the penny hits the ground. Where does the penny hit the ground? Right here. Yep. Okay, so they want you to put an X where that guy hits the ground. All right, so now it's got us using the trace key. When we use trace, okay, we only use the side-to-side arrows. Okay, so trace, is that this button? I can't read them. Or is it this button? This one? So it's next to graph. Okay, and they want to know how many seconds did it take for it to hit the ground. So you can use your over keys. Where did yours pop up? Mine popped up right at the ground. Did your guys pop up at the ground? Nice. So what does that mean? If x is 5, what does it mean? At 5 seconds is how long it took the penny to hit the ground. So write that in part A. Okay, make sure you're writing these answers because I'm going to grade this worksheet. All right, so then it says how far off the ground was the penny at 0 seconds. So at 0 seconds, what has to be 0, the x or the y? The x is going to be 0 seconds. So use your over key where you get x to be 0. Yep, and it's going to be at the top. Can't hit mine too fast up here, it goes crazy. Right? So, how far off the ground is the penny at 0 seconds? 400 feet. Okay, part C says, how far off the ground was the penny at 2 seconds? So what needs to be 2? X. So we're going to use our arrow till X becomes 2. Okay, now here's the deal. Mine jumps from 1.91 to 2.02. So we know it's going to be a little bit over 341, or a little bit under 341 and a little bit over 334. So we can say it's about, what? 335, 336-ish, probably. Is this making sense where we're coming up with these answers? Okay, then it says about how many seconds did it take the penny to fall 200 feet. Okay, so here's the deal. If it starts at 400 feet and it falls 200 feet, where's it going to be? Okay, and what's my halfway point going to be? 200, right? Because half of 400 is 200. And where is that going to be? So I'm going to find y, where y is what? 200. So let's go to where y is 200. It's about what? Okay, so yep, but they want to know how long did it take. So about 3.5 seconds. So it took about 3.5 seconds. All right, and then the last one says how many seconds did it take for the penny to fall 300 feet? Now, am I looking for y is 300? Am I? Okay, so here's the deal. If I drop a penny from 400 feet and it drops 300 feet, where is it going to be now? So I'm looking for where y is 100. Yep. So be careful with what they're asking. And y is 100 at about, yeah, maybe 4.3, well, yeah, 4.3-ish seconds, I would take. Christian, you doing these with us? Okay, if you do these with us, and that it'll be a lot easier to stay awake. All right, so the next one, okay, says the height in feet of a golf ball hit into the air. So what's the difference between this one and the last one? If I'm hitting the golf ball in the air or if I'm dropping a penny off a building?
What's going up in the air?
Yeah, so if I hit a golf ball in the air, it's going to go up and then come back down. Okay, so my time, I'm going to want to see that whole thing, whereas if the other one, it's just going straight down. So, go back to y equals. Okay, we're going to keep, and I'll give you a clue, we're always going to keep this negative 16t squared because that's what represents gravity. Okay, so anytime something's falling, that's what that's representing, is that negative 16t squared. And then we're changing that other part to, no, just plus. So I know that it looks funny in yours because the page number runs into it. It should just be 64t or 64x. All right, so in number 1, it says that they want us to edit the window values to make your graph look like the one on the right. Okay, and then they give you a hint. It says that use the x-min from the penny problem, okay, change the x-max. What do you think the x-max is on this window? Let's count. 1, 2, 3, 4. It goes out to 5. So if I go back to window, we're going to change the x-max to what? 5. Okay. We're not going to touch the y-min. I'll tell you in most of these we don't touch the y-minimum. Okay, but we are going to have to change the y-maximum. Do you think we're going to have to bring this down or up? Down? What do you want to try? 64? All right, so if we try 64, okay, like I said, this is guess and check. Hit graph. Does it look like the one in the window? It's pretty darn close though, isn't it? A little bit, yep. So I'm gonna go back to window. Do you think I'm gonna have to go up a whole lot more? No. What do you want to try? 75 maybe? Oh, that looks pretty darn good. Okay, so those of you that weren't trying these with me and weren't paying attention like we should be, we have our x min is 0, our x max is 5, our y min is negative 10 still, and our y max is 75. Everybody's got their window figured out? Okay, now we're going to hit trace again. The maximum height of our golf ball, so we got to get to the top of that parabola. There I get to, it gets up to 63.99 and then starts coming back again. So we can say our maximum height was 64 what? Feet, yep. Okay, Taylor, do you need one if you need one? Alright, so our height was at, how long does it take it to reach that height? About 2 seconds, yep. And what were you looking at to find that 2 seconds? The x, yep. Okay, and then we're checking to see how long it took it to hit the ground, right? So, I just did it a lot of times, and now I'm going to be in trouble. Oh, no, stop. Oh, that's good. So it hits the ground about, when? About, we can round it to a whole number. What would it be? About 4 seconds, yep. All right, and then part B kind of is a little bit crazy. So they want to know for how many seconds is the ball more than 48 feet up in the air. So if I use my trace button, I'm getting up to above 48 feet at what second? Well, let's say at about 3 seconds, it's above 48. Okay, and then is it above 48 as I keep doing this? Yep, it's still above 48, still above 48, still above 48, still above 48. When does it drop below 48? At about, well, let's say at about 1 second. So from 1 second to the 3 second mark, it's above 48 feet. So how long does it stay above 48 feet? About 2 seconds. Yes, good job. All right, so I'm gonna help you set up this next one. Okay, but after that, you guys are gonna be figuring these out on your own. So you're gonna want to pay attention to this one, because I'm gonna help you get your window to where it needs to be. But after that, you guys are gonna have to do your stuff on your own. Okay, so think about this: you're on top of a hill, and a rocket is launched upwards from a distance of 80 feet above a lake. Okay, what does that mean? Okay, so it means I've got my lake here, and I'm on a hill right here. How high is my hill? 80 feet. So this is 80 feet high, and my rocket is getting launched from right here. Okay, so it's going to go up, 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 right? Before it drops into the water. Okay, so that's what this 80 right here stands for. Okay? So we gotta change our equation. Negative 16x squared plus 64x plus 80. Maybe if my calculator stops going crazy. There we go. Everybody's got it in their calculator? Yes, no, maybe? Okay, so hit graph. Doesn't quite look right, does it? All right, so if we look at the scale of this window, because it gives us this picture over here, what should our x max be? 2, 3, 4, 5, 6, 8, 9, 10. Okay, so we're going to go to window. Now, take a look at this. Can I see the top of this? No. All right, so if I go to window, we know that our x max is going to be 11. Is 75 high enough? No. Now, let's think about this. It got launched from 80 feet, right? And then it went up from there. So we know it's going to have to be higher than what? It's going to have to be higher than 80. So let's make it 100. Okay, let's see how that works. Can I see the top? No. Okay, so we got to go back to window. The only thing we're changing is the y-max. 120. I heard. Still not quite high enough. 150. High. Oh, that's perfect. All right, so your y-max should be, what did we just say? 150, yep. Good job. Okay, so you're going to sketch this over here. Okay, when you are playing with your window, a couple things that I want to warn you about. Let's see. What do I want to do? Is this where I'm at? All right, so a couple things that I want to tell you. If this is your picture, not good enough. Okay? You need to play with your window so that you can see the majority of your graph. You know what I mean? Okay? You shouldn't have, if you cut this into thirds, your graph shouldn't fall below that top line. Okay? But after that, you guys should be able to do these. What is the max? Well, okay, so maximum height you should be able to do. It says how long does it travel upward before its engine burns out? Where do you suppose its engine burns out? Yeah. Okay? Because its engine's going, it probably burns out. And now it's starting to come down, right? Okay? So you guys should be able to finish this